Hello Spark fans and welcome back to Advancing Spark, where today I am super excited because we're looking at Delta Live Tables for the first time ever. So DLT, Delta Live Tables, they are just released in public preview. So it's one of the previews where you need to get hold of Databricks and ask them to enable your workspace, so you might not see any of this stuff in your workspace yet. But I wanted to give you that first idea of what they are, how they work, what it actually means, what it's like to work with them, on all of that good stuff. Now, I made this video first and dove into all the weird config and workarounds and ways you can get into the detail. And then I thought, maybe that's diving in a bit too far. Let's reel it back a bit and talk about what they are, some of the fundamentals of what goes into it, and how you implement the very first getting started demo, just to give you that context of what it is, why it's working the way it's working, kind of what you should be expecting from DLT. And then we can go from there. So take a step back, deep breath. Let's have a look at what Delta Live Tables actually are. So what are they? How do you define them? I mean, essentially, it's a managed workflow for loading Delta tables. It's kind of it in a nutshell. So it's a new load of language type, a load of expressions to define how tables depend on each other. So it's dependency management. It's a new type of job. So it'll run it for you. It'll look after the update of those tables, whether that's a continuous stream or whether that's a nightly incremental load. This also encapsulates the cluster settings and some of the configuration, the libraries, and all of that kind of stuff can be bundled into it as well. And then on top of all of that, you've got some really cool features where they've got things like expectations baked in. Now, if you've ever used Python's Great Expectations library, this would be very, very familiar. This is all about saying, I expect that this column equals this column's less than this, and that's not null. And you can define these data quality measurements and it will automatically track them. So give you an audit log of the quality of your tables. And it will also do things like rejecting rows or failing the job if certain tolerances are met. So loads of interesting things we can bake into it. And essentially it's all trying to work to make that whole job of saying, I've got all these messy sources of data and I'm trying to populate these curated, nice, managed, engineered tables for my analysts to use. And there's a load of steps in between. And I need that to be easier and managed. And I don't have to build a load of frameworks and engineering to make it happen. That is the aim. Now, it's still very new. There's still some gaps. There's still some parts where I'm looking at going, does that work for everything? But again, we will see our patterns change and evolve as things like this come out. And we can try and adopt and work through it and figure out what's the best way of working with this stuff. So interesting times, certainly. So join me on an adventure having a look at the very first quick start for Delta Live Tables, how you get started with it, what it looks like, and how it works. As always, if you're new around here, don't forget to like and subscribe. Let me know down in the comments what you think of all this stuff. Are you excited about Delta Live Tables? Are you going to use it? Let me know at the end of this, is that actually what you thought it was? Which will be interesting from expectations versus marketing and the buzz versus what it's actually like to use it. So let's see. Right, first things first, all the docs are now live. So whether you're in Azure, AWS, GCP, you can go and have a look at the Delta Live Tables user guides and just have a look at all the config, the settings, the reality of what it's like to work with it. So all of that is now there. Go nuts, go have a scoot through. I want to give you a little bit, so in terms of this is quite good in terms of just setting up some concepts. So first and foremost, we have a thing called a pipeline. A pipeline is a chain of related, kind of like table creation scripts, essentially data frame definitions. So I can say this pipeline is made up of a table, which is based on reading this data. Another table, which is based on cleaning up that first table. And then a final table that's based on doing some aggregation and summarization and adding some logic, enriching the intermediate table. And that would represent a Delta Live Table pipeline. And that's the first nuance, is a Delta Live Table doesn't just mean one table, it means a pipeline of tables, which is a little bit weird. So you'll get that. So inside that you have queries, and that's what defines your individual tables. Now you can have a mix of tables and views. So some of them, it'll materialize down into your lake as a Delta table. Some of it, you're just having this as a step in your pipeline. It can just be a logical view that you then reuse in other ways. So it doesn't always have to materialize that data. It's kind of up to you. Expectations is when we're talking about these data quality metrics that it's going to be looking at as we move through things. And that can either keep everything and just mark how many rows failed a certain thing. It can kick out rows that fail a certain metric, or it can break the whole job if you meet a certain threshold. So lots of things we can do in there. Then everything else is kind of all around how we actually then trigger it and work with it and orchestrate it and what configuration we put into those runs. So I'd say as long as you've got those three things kind of in your head, there's a pipeline definition of what are all the different jobs actually involved in this whole thing. Individual table definition scripts, which is just Spark data frames. And then this whole idea of expectations that we can bake into this process to manage data quality. Get those in your head and we're probably in a good state. So what we're going to do, we're going to dive into the quick start and we'll have a look at what that code is, blah, 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 loads of stuff. So it's got this big chunk of Python script, which is going to go and define a Delta Live table pipeline for us. So let's dive into Databricks, going to create a new one, going to create my code example. So it's just creating a new Python notebook. It doesn't really matter what cluster we put it on. We can go and just put that in. There we go. So I've got this. Now, first and foremost, the biggest fundamental confusion I've found in Delta Live tables is this script. Despite the fact I'm on, I'm on the 8.4 beta. I'm on the most recent Databricks runtime. Like, you cannot get more recent. This is the beta version, and that isn't going to work. So I can run this, and it'll go no module named DLT. So this thing at the very start, the very first line in my command, doesn't work. And that's going to trip up quite a few people, I reckon. Because you're going to pick up this script, go, look in the docs, see a quick start, go, okay, this is my code example, paste that into a workbook, and that's not going to work. So fundamentally, currently, you can't run the actual pipeline definition as a standalone notebook. This is expecting to be run as part of a Delta Live table pipeline. So unless you're running it as part of a pipeline, it's not going to understand the various DLT commands. So don't worry if you see that. That's meant to happen currently. You cannot run this. Essentially, you build up your pipeline definition, and then you step over into Delta Live tables pipelines to run it, to develop it, to see if it works. Really confusing when you first start with it, but just trust me on that fact. Okay, so what's actually happening inside this code? So importing DLT, trust me. Importing PySpark functions and types, sure. And then they're pointing it at some JSON that just lives in the Databricks datasets. So if you're not familiar with that, every single Databricks workspace is automatically mapped to a whole big pile of sample datasets. So you don't need to bring your own sample data. This code will run in any Databricks environment. And then they're just pointing at a single JSON file. They're saying, go get some JSON data and we can work with that. So that's fine. We've then got this at DLT table. So what we're doing here is we're defining, essentially this is a create table function. So I think kind of that is an alias for create table, which I think makes more sense when you see it like that. Okay, I'm creating a table, but just for code simplicity, it's always written as table. So I want to say I'm defining a new Delta Live table, and that's a function. And inside there we can have, so it's currently got a comment, we can have names, we can have more definitions, there's some settings we can add into our table there. And then what it's going to do, that's going to look to be followed by a function. And that function needs to return a Delta table, a data frame, essentially. So we're saying, I'm going to define this new table. That table is going to be called, and weirdly, it's going to use the name of the function to decide what that table's called. So clickstream raw is the name of my Delta Live table, which I know is a little weird. And then from that, how am I going to define that? Well, that's going to return a data frame, and that data frame is spark.read.json going to that path we had earlier. So inside all my steps, in terms of what I'm going to see a Delta table called clickstream raw, and it's going to be based on just reading that JSON file. That's what all of that is doing. It's saying there is a step in my pipeline, which is defining this clickstream raw Delta table, and this is how I define it. And I know all of that is new and weird. And for me, it weirds me out that there is this DLT decorator that just assumes there is a function that follows it. But that is how it works. So Delta Live table, some settings, and then a table definition. And then the next thing we've got in our sample script, we've got the same thing again. We've got another separate DLT table. So we're saying, well, we've had one table, define another table with some other settings. And I'm saying, well, in this, I've got 2 additional decorators that follow that create table decorator that are defining expectations. So I'm saying there's a new step. Step 2 in my pipeline is to find this next table. And when data is going into this table, I want you to measure data quality. And I've got 2 expectations I'm setting here. One is saying, make sure this is not null. And one is saying that this value is above 0. So I've got 2 different things I'm trying to measure as I go in there. And that's going to create another table called clickstream prepared. So in my pipeline, I'm going to see a step called clickstream raw and a step called clickstream prepared. And then what that's returning, one DLT.read, not Spark.read, DLT.read. So I'm saying, well, actually, I'm having a Delta live table that's dependent on another Delta live table, and it's dependent on this Delta live table. So it's referring to a table called clickstream raw, which is the name of the function I used to define the earlier table. So it's saying this is dependent on that function, which is part of an earlier table statement. So that's creating dependency. That's saying, well, this thing can't run until I've ran that thing. So I run the first one to get the raw JSON. Then I run a next step by querying deeper onto that table. And then the rest of it's just Spark stuff. With column rename. I can do group by aggregates. Anything I want to do in terms of PySpark data frame definition, I can just add in here as part of that command. And then I've got a final additional table saying, well, this one could be called top Spark referrers, which is reading that middle table. Again, we're using Databricks parlance. Then the first one, that's defining our bronze table. Next one, that's defining our silver table. And then finally, we're defining our gold table. We're saying, well, go get that middle intermediate clean table. Filter it, add a column, sort it, and take the top 10. Again, just normal Sparky kind of things. But it's very, very weird when you first get used to it that you're looking at all of these decorators on your code, which you can't run inside this normal notebook. So you just kind of have to just take it for granted it's going to work. So how do we actually run this? How do we make that do things? It's a good question. So over here we have jobs. Let's go down, hidden on my screen. So we've got Delta live tables. You can see I've been doing lots of things in here and lots of things that are breaking because I've been experimenting and trying various fun things. So I'm going to create a new pipeline. This is create a new Delta live tables pipeline. This is going to be my DLT. So my DLT example code Python. Again, I can do everything in Python or SQL. I need to point it at that notebook. It's that notebook that I just made, DLT. I can't even remember what I just called it. Is that the code example? I think it's code example. Let's just going insane. So let's stick with code example. Let's just make sure we're looking at the right thing. So DLT, code example. Yeah, that's the thing that we just created. Okay, good. And then storage location. Where do I want it to live? So there's a couple of things that this is going to be in here. So call that DLT example. So I'm saying I want you to go and store data in my lake. And that's going to be both storing the actual data for those Delta tables. So inside that pipeline definition notebook, I've defined 3 different tables. And they each need somewhere to live. And I need to write that as a Delta table somewhere. But also, as part of this pipeline, there's a load of workflow, like starting the cluster, stopping it, getting the job, getting the data quality outputs. That are going to be spat out as an additional kind of system audit Delta table. And that's also going to live in my lake. So this location, I'm going to see a couple of things, both tables and my system event logs. Okay, other bits and pieces that we have in here. We can choose to run this in a triggered or continuous way. So I can either say this happens to run once or run in the continuous way. AKA, is it streaming or batch? And then finally, I've got a cluster definition. And you can see that is between 2 and 6 dBs per hour with no sliders, no settings, nothing I can do. So by default, it assumes a cluster size for you. So what I'm going to do in the interest of time, I'm just going to get this started and explain what I'm doing in a second. Okay, so that's now started my pipeline. So the first thing I did, you saw me, I switched from production into development. So there's basically you have a mode. Are you in prod mode or are you in dev mode for a Delta live table pipeline? Now development mode means it's not going to instantly turn off the cluster when it's finished. So what this is going to do, it's going to spin up a job cluster. So it's a single serving cluster. It's not using one of your existing clusters. It's going to spin up its own cluster that'll live for the lifetime of this run, and then it'll shut it down. If I switch it to dev mode, it's going to reuse that existing cluster so I can start it, stop it, start it, stop it. and it will actually not have to wait for that cluster to spin up. Essentially, it gives the cluster a time to live. Also in production mode, there's a few kind of black boxy settings around cluster retries, around restarting the cluster in the event of a failure, doing certain things to maintain and manage and basically productionize that cluster that it does for you that you can't really get at. So different settings, different things that it's doing. And it was very weird for me when I first started that it's just going to pick a cluster size for me. It's going to make a load of assumptions. You saw when we were in that definition step, there weren't a lot of settings in there. It wasn't really a lot that we could do. Now, the good news is that we have this edit settings button, and that just shows us some JSON. It's like, right, there's some settings in there. And essentially, that's just the basics that we saw in that real simple UI when we started. Now, if we wanted to dig into the details, we can do. That's the good news. So if we go back to the documentation, so there's a load of stuff in here. If we look at the Delta Live Tables configuration, it's got a lot of things, a lot of settings that you can have in there. And these are all things that can go into that JSON script. So we can have configuration, we can have Spark cluster settings, we can have library dependencies. There's lots of stuff that we can plug in here that it interprets. They're not exposed in the UI, but you can enhance and augment that JSON settings file to get a lot of stuff. So for example, if I'm not happy with it just picking its own cluster definition for me and deciding how big it should be, I can include a snippet of JSON. I can say, well, actually, no, don't decide what my cluster look like. I'm not going to edit this one because it's currently running. If I go and step into another one and we go back to jobs, if I grab just a previous example, one that I've done before, go into edit settings, we can do that. So we can actually just take that example bit of clusters and say, ignore the cluster that you think you want to be running on. The default cluster for this, it should use this VM type, this VM for the driver. This is how many workers I want it to have. And you can define your own cluster. It's a little bit weird that you have to do that in JSON, but it's fairly straightforward. It's not the end of the world. And what you can also do is build a cluster in interactive mode, turn it to JSON, take those settings if you want to know how they define the node type ID, and then just paste that in here. So actually it's not too bad to do. And then on top of that, there's loads of additional config settings you can get. So there's loads of things we can do in here. So again, the things I was mentioning, target is super useful. So if you've got your own Hive database that you wanted to register all these Delta tables in, you can give it that. If you want to pass in a parameter, so we can parameterize pipelines. So actually when we run it, we have a more generic notebook and we pass parameters into a runtime from the Delta Live table. Again, super, super useful. So lots of things that we can do with, we can have a play with it. Just makes it a little bit more dynamic, a little bit more configurable. Just at the moment, it's kind of hidden away inside that settings. So, okay, this is in progress. So you can see it's initializing, it's setting up the tables, it's working on it. You can see it has now opened Spark UI. So that was grayed out before. That cluster has now started in my dev mode, and we can go and have a look. We can see what kind of cluster it's set up. So that was from me not doing anything, just going next, next, next. And you can see standard F8s with 1 to 5 workers and auto scale. So it's picked a compute optimized cluster, which is interesting. And it's automatically turned auto scale on, and it's using a custom runtime. Now, again, I don't know if that is just because it's in preview currently, or I don't know if actually when this goes live, then it's going to be baked into the standard runtime and it won't need its own Databricks runtime version. I really don't know if we're going to be able to just run that notebook in isolation. Remember, we can't run that import DLT with all its create table and expectations decorators in situ. We have to do it through a Delta Live table. So it's kind of interesting. It's kind of a weird way of working. But at least the good thing is once that cluster is set up and once it's actually got on top of how it should be working, if we're in development mode and it leaves that cluster turned on, we can make some changes, hit go again, make some changes, hit go, make some changes, hit go. And it's actually a little bit quicker to work. We can kind of step back and forth and work in a more sensible way. Okay, so whilst that is off and running, let's just make sure we're all on the same page for how that example code should work. Because what I was having a play with in terms of in here, if I just grab that piece and explain where I was going in some of my mad experiments. Let's go DLT sandbox, create that. Okay, so the thing that got me really confused here is kind of just there was lots and lots of stuff that was going. And essentially, if we bake this down essentially what we have, again, we use the other alias, then we make it a bit more sense. So you've got DLT create table as a function. Follow that with whatever a function name is. And that is also your table name. So that is going to be the Delta table that's gets created. And then we have, this just needs to return a data frame. And for me, I was looking at going, well, that's really weird. The fact that this has to be, the whole of your Spark.read with all your options, with column renames. And that's, if you're doing a lot, you can have a huge thing in there. I had a play on what you can actually do inside this function. You can do this Spark.read.csv or whatever it happens to be. Get all that working, do all your whatever that needs to be. And then as long as this returns a data frame, then that works. That's absolutely fine. So don't feel that you have to encapsulate the entirety of logic inside that one return statement. You can actually build this into a larger function and call other functions and do all that kind of stuff within that live table definition. So it's a little bit weird when you're first looking at those demo scripts as to how you think you have to structure the code. Essentially, that's what it needs. It needs the decorator saying I'm creating a table. It needs a function defined with whatever that name should be, and needs to return something. And actually, you can get even fancier, because actually inside this table function, I think we saw in the example it had, kind of the comment equals, it had that kind of stuff. We can also have name. So rather than it having this function name being automatically inferred as the name of the Delta table, we can just call it in there. So there's some more stuff we can get to. We can get deeper and deeper into the settings of that stuff to try and actually get a bit deeper. So I don't know why my graph's not coming up, but we should see that in a sec. And then what we've got is you can see in all these different flow updates that it defined my table, it defined my things, it finished writing the data into it. So you can see it's going through and actually running that process. So it's defining data sets on the fly. And we've got each of these is a nice little event message. So we can go and see what's happening inside there. What happened there? What's the structure of that particular step? So it's capturing lots and lots and lots of definition information, running information, config. Oh, there you go. You can see it's now actually kicked off. So it's actually got my graph. I don't know why it's not showing my graph properly, but still, there we go. So you can see it's figured out it's got those three tables that are dependent on each other. So it's got a raw table. It's got an idea of the structure of that. It's got my prepared table, and it knows that raw goes into prepared because we had that DLT.read going from that earlier one. We're building up our dependency chain inside it. We've got a top Spark reference. So we've got that final one, which we know is based on that, which is based on that. And it's building out, it knows that it has to work through and build all of that stuff. So it's kind of interesting in that it's automatically doing that production of dependencies. It's automatically building out this hierarchy of dependencies of our different stuff. Now, yeah, this is fairly easy. This is a nice one-to-one linear dependency. And it's going to get interesting when we have whole mixes of different things based on different things, based on different things. How is that going to work? So you can see we've got one of the flows completed. So it's finished loading raw. You can see inside there, it knows how many rows it's being processed. It hasn't done any data quality because we didn't have any expectations at the raw step. And it'll build out all those different steps as we go through it. So essentially you have like little automatic logging of telemetry, especially when we got those expectations in. It's going to tell us how many rows it loaded in each of those steps as it goes through and builds out. Interesting stuff. While that is happening, I want to switch back into our little quick start just to show you the other side of things, which is the SQL side. And that is so interesting because essentially this Python script, it's a little weird to get started with. The idea that we've got these table decorators of @DLT and then assumptions that that's followed by a function, it's a very weird way of writing Python, honestly. As someone who I spend my life writing Python data, like of engineering frameworks, and it's all very confusing the way it's built. And it's basically because it's being picked up by a different parser, which is going to work all that stuff and then turn that into a different set of code to actually run. It's very powerful, got lots of stuff in there. It's just slightly odd in terms of how this is actually built up. When we have a look at the SQL side of things, we can do the exact same thing in SQL. And actually, syntactically, it's just much simpler. Makes a load more sense. So create live table, this, as select from JSON. Super easy, super straightforward. So that first bit, that whole thing is essentially implemented just as a straight create live table as select star from. Really, really easy. Building up the next one. So I'm saying create a live table, call this. Here's my constraints that I want to put in. I'm putting them in as expect constraints, but I can still do the same thing. I can build up my list of expectations, I can add in my comment, and I'm just telling it to select from live.clickstream_raw. So again, live is that the same as that DLT.read that's saying pick it up from live, call clickstream_raw, go find it there. So that whole bit of SQL is doing the exact same thing, but I think for users who are used to writing SQL, that is really easy. That is really, really, really straightforward in terms of what's actually happening in there. Now, from the Python point of view, there's lots of stuff in there that's going to be doing things like dependency management and data quality management and managing the write of those tables and all that kind of stuff. And actually, we can already do a lot of that on the engineering side. People have their own patterns. They have their own ways of working for that. On the SQL side, allowing someone to write a little bit of SQL and have that automatically manage dependencies and data quality metrics and all that kind of stuff by having some fairly simple, recognizable syntax, that is huge. That is really, really, really powerful. So it's going to be interesting as to how many people actually, where people go. Are people going to dive on the Python stuff and start pulling it apart and trying to make it dynamic and generic, trying to make it much more, I want to build one generic pipeline definition and then actually use that to process hundreds of tables, thousands of tables? Or is it going to be more that people are going to be pushing out SQL ones and then pushing that to more your data analysts and your business users who are fairly data savvy to actually define their own things? And this is going to automate away a lot of that pain that we need to worry about in engineering. And it's going to be interesting to see, is it going to be a mix and match? Like a managed central pipeline and then people branching off into their own analytics data marts that they can have produced in a dynamic, managed, productionized way. Loads and loads of stuff in there. That's all super, super interesting. Okay, well, how are we? Are we completed yet? There we go. So you can see this whole thing is now completed. So the end of the update is completed. So you've got your update, which is like the whole workflow. And so there's no data metrics in there. This isn't at the data level. This says my orchestration tasks have completed. I don't need to kick off any more orchestration. Whereas in my flow, I can see, well, the flow for Top Spark referrers started, ran, completed. The flow for Clickstream prepared started, ran, completed. And in that Clickstream prepared, that's where I had my data quality expectations. And we can go inside that message. We can see details of the flow, total number of rows processed. I didn't drop any records because none of our expectations were expect or drop. So the ones that we just had a straight expectation for, we can see it passed so many records and it failed 5 records. So it's building out, it's doing that counting of the various things. We have automatically done data quality benchmarking, and we know that there are 5 records that don't have a valid page title, but we don't want to fail or load because of it. We can then put on dashboards and examples and things. We can pull that out and have a DQ dashboard based on the expectations that are met or failed. Interesting. Okay, so that's the basics. So that is that quick start, right? That is that real simple linear dependency. Everything's hard coded in there. So that example that we put together, that example bit of code, it is just going from one fixed hard-coded JSON table to another fixed hard-coded table that relies on it to another fixed aggregation table that relies on it. We're not getting any code reuse there. We're not kind of getting any parameterization in there. It's a fairly simple example that hopefully kind of gives you that idea of Delta live tables aren't a new type of notebook. They're not really the new type of job. They're a combination. They're a special type of job that expects and interprets certain commands that are hidden inside a notebook that will then allow it to do things like manage dependencies and manage data quality for you. Loads and loads of stuff in there. Now, the final extra thing to be aware of, I think there we go. So what happens once you've got this deployed? It's automatically going to run every day. And that I was like, what? It's going to do what? So because this is a job, because this is a live tables job, once it's actually sort of set up and running, every day it'll spin up a job cluster on its own, however you've defined that, run your whole list of dependencies and update that data. And there's deeper things we can do inside each of these table definitions to say, is it an incremental? Should it only take what's changed and stream it across? Or should it be doing a batch load and trashing it and replacing it each time? Should it just be doing a view? Does it need to land this data down? Or is it actually all ephemeral, and this is just a logical step in a wider flow. Lots of different nuance in terms of how we can set these things, and that is a whole different video. We're not going to go into that now. The final thing I want to show you guys is that example that we had, so I told it to write into my lake, into this DLT example folder, and you can see it automatically breaks it into two. So I've got my system folder, which is all of those events. So when I'm here and I've got this bit at the bottom, all these different JSON records, which is explaining this is what happened. I started a cluster, I ran this table, I got these data quality expectations. That is just another Delta table that I can go and query. And then I've got my tables, and you can see in my tables, I've got my different tables that were defined, and they are Delta tables of their own. So it's still managing things, it's still managing its Delta, it's still landing the data in your lake. It is just a Delta table. It's just a whole management layer on top of your Delta table to automate away data quality and dependency management and running and updating of these things. Yeah, so loads of stuff in there. So hopefully I've restrained myself. We didn't dig too much into the weird and wonderful and what you can do in terms of the config. Hopefully that gives you a good idea about what Delta live tables are. So there's a load of new commands in config we can put inside of a notebook to actually give Delta live tables hints about how to build up a chain of interreliant Delta tables, about how to manage data quality. We can build our Delta live table pipeline, which works very similar to a job with some extra config, and that will automatically look after the running of that notebook, the populating of those Delta tables down that dependency chain, and the tracking of lineage and auditing, and some of the restartability, some of the what to do in an error, some of the how to start up a cluster and how to manage that cluster. A lot of that is taken care of for you. Still lots of things that are a little bit black boxy. Still lots of things I've no idea how it works. I've not looked into it yet. Still very early days in terms of the preview, in terms of how people are going to use these and what patterns we're going to see come out of it. But definitely very interesting way of doing things. Loads of thoughts on my side going, where do I want to use that? What do I want to integrate that with? What do I do in my existing patterns? How much of that do I strip out and just go, this does a lot of the stuff I already do? And how much do I want to keep my own custom things because I've got more control? I've got a lot more nuance about what I can do with it. And that might be the answer, really. It might be, if you've got very experienced data engineering teams who are building their own things, then this isn't for you. If you've got teams who you don't already have a framework, you haven't invested in terms of building out lots of data management libraries, and you just want something off the shelf that's going to manage this chain of events and actually manage getting data in there with fairly hassle-free, then actually maybe this is going to save you a lot of time. And yeah, super interested to hear what you guys think. Let me know down in the comments what you think. Is it what you thought it was? How do you think it's going to use it? Anything in there you've gone, whoa, okay, that wasn't what I expected. Love to hear. Let me know down below. As always, don't forget to like and subscribe. Check out our other videos for the world of Delta and Spark and other bits and pieces. Otherwise, I'll see you next time when I'm probably still going to be digging into further deeper things here. So, cheers.